Hey, we're going to talk about some riverboat problems, the classic vector problem that we all love so much. Hey, we have this boat that's going straight perpendicular across the river. And we're just going to make up a speed here. We're going to say this thing is going, um, let's say 5 meters per second. But that raging river is just flowing uh, north, I guess I can call it. Doesn't really matter which way it's flowing. And we'll say that that is flowing at, let's say, 10 meters per second. We don't want to have too complicated a math, do we? All right, so we have these two things. Now, both of those forces, the paddler and the river, are acting on that canoe at the same time. So what that ends up is giving us a vector addition problem. So what we need to do is redraw our triangle. Some people call it tip to tail, head to tail. It doesn't matter what you call it, but you put the base of the arrow and the tip of the arrow are going to touch and pointing at the same direction. Hey, I drew that to scale. I didn't have to draw that to scale, but I did anyway by accident. Okay, so we had that set up. Now this was 5 meters per second, and this was 10 meters per second. Hey, let's change fonts. Okay, we'll change colors too. All right, now let's complete this vector. So the result of those two vectors, the resultant is from here to here. All right, this is obviously a right triangle. All right, and we just need to find out what the resultant is. Now, I would use Pythagorean's theorem because, that's my thing, right? So 5 squared plus 10 squared equals our answer, our resultant squared. So R equals, and that's what we're trying to find. Okay, calculator wise, I'm going to have to do a little quick zip here. Calculator, and that's on the wrong thing. Let's put it on just basic. All right, so we have 5 squared plus 10 squared equals, and then we have to take the square root of that because that's R squared yet. Take the square root, and we get 11.2 meters per second. All right, now that's R. But okay, we also have to find that angle. So let's see what we have for that angle. Well, we have 10. 10 would be the opposite side. And then we have a 5, which would be an adjacent side. So opposite over adjacent, that's tangent, right? So we're going to have to use our tangent. Now we're trying to find the angle. So what we're going to have to do is we're going to have to use the second or the inverse tangent. So take the tangent, the inverse tangent of 10 divided by 5. Now, in your calculator, if you have the Texas Instruments calculator, that's not a Z, that's supposed to be an equal sign. If you have the Texas Instruments, it'll look just like that when you plug it in or something similar. If you're using a calculator like I have right here off your iPhone or iPad or whatever you have, you're going to have to do the fraction first. It's just the old school way. If you're not used to this, then use your other calculator. All right, so let's see what we got here. So, oops, let's see, I already have it in there because I messed up the first time I recorded this because I was in radian mode. So we're going to take 10 divided by 5 equals. On this calculator, you have to push the equals first and then your second tangent. So you have to look for this one has a shift button. We don't want tangent, we want our tan negative 1 there, and then 63.4. Okay, I hope that helps. Have a great day. Oops, let me just finish it out on the paper, huh? So we have, was it 61.4? If that was the wrong answer, just ignore me. Okay, and then that was our angle. All right, I hope you got that, and good luck.